Good evening to all my friends and Madam Liu. Today, my group present about vector and scalar in engineering. This is our content. We have 6 content. We have 4 members in our team. First, Lokman Hakim bin Jais, matric number F1094. Second, this is me, Siti Nur Adawiyah binti Ishaq, matric number F1092. And third, Muhammad Alif Aiman bin Abdul Rahim, matric number F1118. And last, Syamil Hakim bin Shahazlan, matric number F1087. Then now, introduction. Vector quantities, a quantity that has magnitude and direction. Example of vector quantities are displacement, velocity, direction, momentum, force, lift, weight, and dot. And second point, scalar quantities, a quantity that has magnitude only. Typical example of scalar quantities are time, speed, temperature, and volume. Scalar quantity or parameter has no directional component, only magnitude. For example, the unit for time is minutes, days, and hours. Represent an amount of time only and tell nothing of direction. Actional example of scalar quantities are density, mass, and energy. Next, I will present about application of vector and scalar in selected area. Vector can be used by a traffic controller when tracking plane, by meteorologists when describing wind condition, and by computer programmers when they are designing virtual worlds. In this section, we will present 3 applications of vector that are commonly used in the study of physics, work, torque, and magnetic force. Second point, scalar, a physical quantity that is completely described by its magnitude. Example of scalar are volume, density, speed, energy, mass, and time. Other quantities such as force and velocity have both magnitude and direction and are called vectors.
Okay, let me show your question in vector and scalar. First question, consider the 2 vector A and B shown in figure 2. Suppose A has modulus 4 units, B has modulus 5 units, and the angle between them is 16 degree as shown. D is degree. Figure 2, A and B have length 4 and 5 units. Respectively, the angle between them is 16 degree. We can use the definition given above to find the scalar product of A and B. AB equal AB cos theta equal for multiply 5 multiply cos 16 degree equal for multiply 5 multiply 1/2 equal 10. So the scalar product of this vector is the number 10. Note that the answer is a scalar, that is a number rather than a vector. So we have learned a method of combine two vector to product of a scalar. Okay, second question to vector and scalar is, suppose for the 2 vector in the previous example we calculate the product in a different order. That is, suppose we want to find BA. The definition of BA is BA equal BA cos theta. Performing the calculation using the number in the example, we find BA equal BA cos theta equal 5 multiply 4 multiply cos 16 degree equal 5 multiply 4 multiply 1/2 equal 10. So we see that the result is the same whichever way around we perform the calculation. This is true in general. This property of the scalar product is known as commutativity. We point it out because in another unit you can learn about another way in combining vector known as the vector product. The vector product is not commutative, so the order in which we write down the two vectors will be very important. Okay, thank you.
So my name is Lokman Kimilais. I'm going to continue some hacking presentation. This is mathematical solution with drawing number 3. Consider the two vectors A and B shown in figure 3. The angle between them is 90 degrees. As shown, you can look at the image. Figure 3, the angle between A and B is 90 degrees. We can use the definition to find the scalar product of A and B. A dot B equal to A bracket and B bracket cos theta equal A bracket B bracket cos 90 degree equal 0. Because cos 90 degree equal to 0. This is true whatever the length of A and B. So the scalar product of two vectors which are at right angles is always 0. We say that such vectors are perpendicular or orthogonal.
As conclusion, the magnitude of a vector can be found using Pythagoras theorem. Also, this can be extended to any number of dimensions. Vectors can be added and multiplied by scalars. You can multiply two vectors together. Then, position vectors are used to describe the size and position of a vector. Scalar multiplication is used to find the angle between vectors. Lastly, two vectors are at right angle if and only if A point B equals to 0.
So this is end of our presentation. If you have any question, you can contact me, Lokman, or my friend Alif. We would glad to answer of any question from you all. Thank you.